Let me do a recap of what are the things that we discussed. First method we discussed negative remainder concept. Negative remainder concept. We discussed what is a negative remainder concept. Then we understood the drawback. Then we discussed Euler theorem concept. Euler theorem concept. In this Euler theorem concept, we have discussed what is a totient function. What is a totient function? Euler's theorem is used when the denominator is a composite number. When the denominator is a composite number. Then we thought, what if the denominator is a prime number? If the denominator is a prime number, if the denominator is a prime number, if the denominator is a prime number, then we discussed another theorem, Fermat's theorem. Fermat's theorem. These are the three concepts which we discussed. In negative remainder, we discussed using models, model 1, 2, 3, till 6 models which we have discussed. And the seventh one is power to the power. 7 models we have discussed in negative remainder concept. Euler's theorem. In Euler's theorem, we also discussed how to find the digital sum. How to find the digital sum of a number. It is nothing but the remainder when you divide a number by 9. That also we used it. Then we discussed denominator prime number. Students who missed out the session 1 and session 2, you can go back to our YouTube channel and the videos are made public. You can watch session 1 and session 2 to get all your doubts clarified. If you are listening to session 3 for the first time, if you are listening to session 3 for the first time, if you are listening to the class for the first time, now see here, right? So in Euler's theorem, we also discussed backtracking method, how backtracking helps us. By today evening, reminder, most of the problems you can solve it. This we solved, this we solved. Let me do question solved, question solved. Question solved, question solved. 5 over 6, 7, 8, 9, 10, 11, 12, 13, 14. Practice problems which we solved. Write all these. Euler's theorem. Euler's theorem. Euler's theorem application. Fermat's theorem. Now we are at. Please write down an important key point. Then we will solve the problems. Please write down. Fermat's theorem, one important conclusion. Fermat's theorem. Let me first discuss what is Fermat's theorem. Fermat's theorem is remainder when a power p minus 1, when divided by p, it is 1. When a and p are coprime numbers, when a and p are coprime numbers, p is a prime number. P is a prime number. Remainder when a power p minus 1 when divided by p, remainder is 1. Remainder when a power p minus 1 when divided by p is 1. A and p are coprime. For me, this is not important. The conclusion of this, I will discuss the proof. Any single digit, any single non-zero digit, any single non-zero digit written p minus 1 times, any single non-zero digit written p minus 1 times, p is not equivalent to 235 is always divisible by, p if p is prime. First write this point, then I will discuss the proof behind this point. It's an extreme important concept. You take any single non-zero digit. You take any single non-zero digit. If a single non-zero digit is written p minus 1 times, p is not equivalent to 2, 3 and 5. P is not equivalent to 2, 3 and 5. It is always divisible by P if P is a prime number. if P is a prime number. Any single non-zero digit written P minus 1 times is always divisible by P if P is a prime number. For me, important key point is P is not equivalent to 235 and a single non-zero digit is written P minus 1 times. Why it is happening? Proof. For everything whatever I discuss, I will give you the proof. Proof. Please write down. Can I say that 10 power P minus 1 divided by P, it is 1 if P is not equivalent to 2 comma 5, because Fermat's theorem is valid when the numerator base and the denominator are co-prime to each other. If I take 2, 10 and 2 factor common is 2, 10 and 2 are not co-prime to each other, 10 and 5 are not co-prime to each other. So 10 power P minus 1 divided by P is 1. Suppose example, 10 square divided by 3, 100 divided by 3, 333s are 99, remainder 1. Can I write like this? 10 square minus 1 divided by 3, remainder will be 0. Can I write like this? 10 square is 100, 100 minus 1 is 99, 99 when divided by 3, remainder will be 0. Am I right? Now please write down these example, then in the next slide I will give you a proof. 10 power P minus 1 when divided by P, it will be 1 when P is not equivalent to 2 comma 5. Why P cannot be equivalent to 2 comma 5? Because A and P should be co-prime to each other. Because A and P are co-prime to each other, so 10 and 2 are not co-prime to each other, 10 and 5 are not co-prime to each other. Now see here, proof. Reminder 1. 10 power P minus 1 divided by P, it is 1. P is not equivalent to 2 comma 5. So if I keep 1 on the left hand side, this will become 10 power P minus 1 minus 1 divided by P, it is 0. If I take P value 3, this is nothing but remainder of 10 square minus 1 divided by 3. This is nothing but 10 square minus 1 is 9 into 1 divided by 3, which is 0. Am I right? 9 is divisible by 3. 9 is divisible by 3. If I take P value 7, 7 minus 1 is 6. 10 power 6 minus 1 divided by 7. 10 power 6 minus 1 is 9 written 6 times, 1, 2, 3, 4, 5, 6 divided by 7 and it is 0. 9 is not divisible by 7. 9 is not divisible by 7. Only in this case 9 will be divisible by 7. 9 is not divisible by 7, but these 6 1s is divisible by 7. 9 is not divisible by 7. 6 1s is divisible by 7. Now what is the point I said? Any single non-zero digit written P minus 1 times is always divided by P. Why P is not equivalent to 2 comma 5? Because P and 10 are co-prime. Why P cannot be equivalent to 3? Why? Because 9 is divisible by 3. Any single non-zero digit, extremely important point, sir. Any single non-zero digit written P minus 1 times, is always divisible by P. Is always divisible by P if P not equivalent to 2, 3 and 5. Please write down. Any single non-zero digit written P minus 1 times is always divisible by P. P is 2, 3, 5. 9 is not divisible by 7. 6 1s is divisible by 7. I hope the proof is clear. Unless you understand the why behind the question, which method to use when, you will not have a clarity. Probably at the end of session number 3, I will give a table when to use which concept. so that complete reminders will be clear. So any single non-zero digit written p minus 1 times is always divisible by p if p is not equivalent to 2, 3 and 5. If p is not equivalent to 2, 3 and 5. Why am I doing this? Because all these examples morning I discussed Euler theorem. We stopped here. We have stopped here. Now see here. Now all the questions are very, very easy. Now see, denominator is 19. 19 is a prime number. 19 is a prime number. What is the concept? If a non-zero digit, 9 is a non-zero digit. If it is written p minus 1 times, 19 minus 1 is 18 times. When divided by 19, remainder will be 0. Denominator is 19. If it is 19, if a non-zero digit is written 19 minus 1 times, 19 minus 1 times is 18 times. Answer is 0. I hope it is clear. One more example. 777 written 10 times is divided by 11. 777 is written 10 times divided by 11. Any single non-zero digit written p minus 1 times is always divided by p if p is prime. If it is 11 minus 1 times, so it is 10 times, so remainder is always 0. Any single non-zero digit written p minus 1 times is always divisible by p if p is prime. This is 37. So this should be 36 times. 136 it is 0. Another multiple of 36 is 0. Another remaining is 7. 7 is written 73 times. 36 times it is 0. Any multiple of 36 times it is also 0. 36 2s are 72. So remaining 173. Answer for this question is 7. Answer for this question is 7. Any single non-zero digit written p minus 1 times is always divisible by p if p is a prime number. Any single non-zero digit. 37, 36 times, any multiple of 36 times. 72 times, remaining is 17. We will do some more questions. There is no debt to the questions. Remainder of 5, 5, 5, 5, 5. Written 34 times. Written 34 times. Divided by 17. Divided by 17. This is 17. Numerator should be 17 minus 1, 16 times. 16 times it is 0. Any multiple of 16, 32 times it is 0. 34 times, 32 times it is out. Remainder is 55. I hope the concept is clear. Till now, please let me know if this concept is clear to you. Only concepts in our class. We should not waste students' time so much. And 90 minutes is 90 minutes of powerful conceptual content. 55. Rizwan, you are right. When you divide a number by 17, you will not get 55. So further divide. 17 3s are 51. Remainder is 4. Remainder is 4. Now another variety of questions. But before that one, we will take an example. Example 1. Remainder of 9 power 8 power 27 divided by 9 power, or we will write down 9 power 18 power 27 divided by 19. 9 power 18 power 97 divided by 8. Now see here. So according to Fermat's theorem, 9 power 18 divided by 19, it is 1. A power p minus 1 when divided by p, it is 1. So 9 power 18, check with this number with this number. So if I do 18 power 27 when divided by 8, 18 ones are 18, perfectly it is divisible. So 18 power 27 is perfectly divisible by 18. 9 power 18k. So this is 9 power 18k divided by 19. 9 power 18 divided by 19 is 1. 9 power 18 divided by 19 is 1. Again I am explaining. According to Fermat's theorem, 9 power 18 by 19 is 1. Check, do this number with this number. Right? 18 power 90, 27 divided by 18. 18 ones are 18. Remainder is 0. 18 power 27 is perfectly divisible by 18k. 18 power 27 is nothing but 9 power 18k. 9 power 18 divided by 19. Remainder is 1. 1 power any number. Answer is 1. 1 power any number. Answer is 1. We will do one more example. 5 power 6 power 29 divided by 5 power 6 power 29 divided by 7. According to this question, 5 denominator is 7. So 5 power 6 divided by 7 is 1. Divide this power with this power. So 6 power 29. 6 power 29 when divided by 6. 6 ones are 6. Remainder 0. So 6 power 29 is perfectly divisible by 6. 5 power 6k divided by 7. 5 power 6 divided by 7. Remainder is 1. 1 power any number is 1. 1 power any number is 1. I will not only solve the problems which are there on the slide. If time be, I will keep creating as many questions as possible, because most of you know that I am an author of 9 mathematical books. I hope this concept is clear. Next, third question. Third one. Third question. Third one. Third question. Let us do it. Remainder of, third example, remainder of 7 power 25 power 130 divided by 13. 7 power 25 power 130 divided by 13. This is nothing but 7 power 12 divided by 13. It is nothing but 1. 7 power 12 divided by 13 is 1. Divide this power with this power. So this will become remainder of 25 power 130 divided by 12. 12 twos are 24. Remainder is 1. So 25 power 130 when divided by 12, I will get a remainder 1. So it is 12k plus 1. It is 12k plus 1. I hope it is clear. So this will become remainder of 7 power 12k plus 1 when divided by 13. So this is remainder of 7 power 12k into 7 power 1 divided by 13. This is 1. 1 sevens are 7. 1 sevens are 7. I hope the idea is clear. Denominator, if it is p, numerator, power should be divided by p minus 1. 7 power 12 divided by 13, it is 1. The entire concept lies in dividing this number with this number. 25 power 130 divided by 12. 12 twos are 24. Remainder is 1. So 25 power 130 when divided by 12, it gives a remainder 1. 7 power 12k plus 1. 7 power 12k by 13, 1. 7 by 13, it is 7. Students who are listening to the session number 3, please go back and watch session number 1 and 2. Already minimum 3 hours I solved problems on reminders. So if you have gone through session 1 and 2, session 3 will be little quick for you. Your understanding ability will be very quick. Now we will solve this 9th problem. I hope it is clear for you. I hope the idea is extremely clear for you. 7 power 7 divided by 13. This is nothing but 7 power 12 divided by 13. It is 1. 7 power 12 divided by 13 is 1. Divide this with this. So this is nothing but remainder of 7 power 7 divided by 12. So here it is remainder of 7 square whole cube into 7 power 1 divided by 12. 49 divided by 12. 12 fours are 48. Remainder 1. 1 sevens are 7. 1 sevens are 7. That means 7 power 7. So here it is 7 cube whole square into 7 power 1 divided by 13. 7 cube. 7 cube is 343. 343 divided by 13. 13 twos are 70. 13 twos are 26. 83. 13 six are 78. 5 square is 25. 25 into 7 divided by 13. 13 twos are 26. Minus 1. Minus 1 into 7. Minus 7. Positive remainder is 6. Positive remainder is 6. This question is taken out from a sub-junior Olympiad paper. Sub-junior Olympiad paper. Listen carefully to this concept. After half an hour, 1 hour, you will solve remainder problems using answer options. Remainder problems using answer options you will solve. Extremely important for any student who is writing aptitude exams where number system is an topic. Extremely important for CAT students, SSC students, bank level students and placement level students. Right? Very important. If you know these fundamentals, the next level of questions, you can solve it very fast. You can solve it very fast. Please acknowledge it in the live chat if it is clear to you. Our live classes should be extremely rigorous and up to the point subject. There should not be any of the non-academic discussion in our class. Non-academic discussion should not happen when a subject is being discussed. A student should see me in the mobile or a laptop, keep a headphone and just concentrate on my teaching. Like the way I am concentrating on that student who is sitting 1000 kilometers away and learning from me. Kindly reply it in the live chat if it is clear to you. If it is clear to you, kindly reply. Sanjeev, yes beta, it is beneficial for SSC. I will take some staff selection commission questions as the time permits. Extremely important, sir. By 4:30, 4:45, complete a picture of reminders, you will get an idea. You will get an idea of various types of reminders, how to solve reminder based problems. How to solve reminder based problems. Right? Clear? Next one. Now, see here. But there is a drawback. Now, listen very clearly, sir. Suppose if it is 2 power 37 by 3. 2 power 37 by 3. 3 ones are 3 minus 1. Minus 1 power odd is minus 1. Positive remainder is 2. This is level 1 question. This is a level 1 question. Remainder of 5 power 37 divided by 63. Which power of 5 when divided by 63? 5 cube is 125 into 5 power 1 divided by 63. 125. 63 twos are 126. Minus 1 into 5. This is a level 2 question. Level 2 question. Remainder 1. 3 power 80. 3 power 80 when divided by 5. I did it by using remainder of 3 power 20 power 4 divided by 25, which is 1. This is level 3 question. This is level 3 question, which is nothing but an application of Euler's theorem. Application of Euler's theorem. There is a drawback in Euler's theorem. There is a drawback in Euler's theorem, which we will discuss. Then we will get into things. Level 1, level 2, level 3 kind of questions. Now, what is the drawback in Euler's theorem? Why Chinese remainder theorem came into picture? Why Chinese remainder theorem came into picture? Suppose, if the question is 3 power 101 divided by 77. Divided by 77. 77 is 7 into 11. 7 into 11. So, quotient function of 77 is 77 into 1 minus 1 by 7. Morning class we discussed why it is 1 minus 1 by 7. 1 minus 1 by 11. 77 into 6 by 7 into 10 by 11. These cancelled. 6 tens are 60. 6 tens are 60. If it is 60, 3 power 60 divided by 77. 3 power 60 divided by 77. 1. What is the next multiple of 60? 3 power 120 divided by 77. It is 1. But the question is 3 power 101. 19 steps I have to go back. 19 steps I have to go back. 19 steps we have to go back. Extremely time consuming. Extremely time consuming process. Extremely time consuming process. Extremely time consuming process. So in this case, Euler's theorem cannot be used. In this case, Euler's theorem cannot be used. Euler's theorem is used. Euler's theorem is used when the power of the numerator, when the power of the numerator is closer to quotient function of denominator, quotient function of denominator or its multiples, quotient function of denominator or its multiples. Please write down. Please write down this important point. Euler's theorem is used when the power of the numerator is closer to quotient function of denominator or its multiples. That is where the usage of Euler's theorem is best. That is where you can use this Euler's theorem effectively. This is where the Euler's theorem is used effectively. Euler's theorem is used when the power of numerator is closer to quotient function of denominator or its multiples. I will take 2 examples so that it will be clear for you. Remainder of 7 power 41 divided by 100. 7 power 41 divided by 100. 100 is nothing but 2 square into 5 square. So, quotient of 100 is 100 into 1 by 2 into 4 by 5. Already we discussed in the morning session. N is P1 power A, P2 power B. N into 1 minus 1 by P1, 1 minus 1 by P2. 10. So, this is nothing but 40. 41 is closer to 40. You can use Euler's theorem. Suppose if it is 3 power 80 by 25. 25 is 5 square. 25 is 5 square. Quotient function of 25 is 25 into 4 by 5 which is 20. 80 is closer to the multiple of 20. Power of the numerator. Power of the numerator. If the power of the numerator is closer to quotient function, or if the power of the numerator is closer to the quotient function multiples, it is closer to quotient function multiples, it is closer to quotient function of denominator, Euler's theorem is used. Euler's theorem is used effectively. But there are a lot of remainder based problems where this condition is not satisfied. If this condition is not satisfied, then how to use it? If this condition is not satisfied, then how to use it? Now, listen carefully. Side heading, write down Chinese remainder theorem. Side heading, Chinese remainder theorem. Chinese remainder theorem. Chinese remainder theorem. Chinese remainder theorem. This is the beauty of Chinese remainder theorem. You can eliminate all incorrect answer options also by using this Chinese remainder theorem. Chinese remainder theorem is used when the denominator is a composite number. When the denominator is a composite number. When the denominator is a composite number. The theorem states, write the composite number as a product of coprimes. Write the composite number as a product of coprimes. As a product of coprimes. Write the composite number as a product of coprimes. As a product of coprimes. That means, and another thing is, if the question is of this form, numerator power x divided by denominator, the best thing about Chinese remainder theorem is numerator and denominator may or may not be coprime to each other. May or may not be coprime to each other. It may or may not be coprime to each other. It may or may not be coprime to each other. First write down as it is, sir. First write down as it is. Write down as it is. Chinese remainder theorem. When is this Chinese remainder theorem used? Chinese remainder theorem is used when the denominator is a composite number. When the denominator is a composite number. What we have to do with this composite number? We have to write it down as a product of coprimes. Coprimes. Here numerator and denominator. Here numerator and denominator may or may not be coprime to each other. This theory. These theory. Practice problems and exercise problems. What is the importance of this Chinese remainder theorem? It helps in eliminating wrong answer options also. It helps in eliminating wrong answer options also. It helps in eliminating wrong answer options also. By using Chinese remainder theorem, you can eliminate wrong answer options. Only wrong, which all options are wrong, you can say. Let us do few examples. Please write down side heading. It helps in eliminating wrong answer options also. Chinese remainder theorem. This is used when the denominator is a composite number. Write the number as a product of coprimes. Write the number as a product of coprimes. Right? Please write down elimination of incorrect answer options. Elimination of incorrect answer options. Elimination of incorrect answer options. How to eliminate incorrect answer options? Elimination of incorrect answer options. Listen carefully, sir. Listen carefully to the, or if I will do few examples, it will be clear to you. Elimination of incorrect answer options. First one, remainder of 5 power 37 divided by 63. Divided by 63. 5, 18, 7, 9. If options are like this, 5 power 37 divided by 63. 5, 18, 7 and 9 is there. See how you should solve. 63 is, write the number as a power of prime basis. 63 is 3 into 3 into 7. 63 is 3 into 3 into 7. Take one prime number and just check it out. Remainder of 5 power 37 divided by 3. 3 ones are 3 twos are 6. Negative remainder minus 1. Minus 1 power odd is minus 1. Positive remainder should be 2. Positive remainder should be 2. That means answer when divided by 3, it gives a remainder 2. Answer when divided by 3, it gives a remainder 2. Check which all options are of the form. When divided by 3, it gives a remainder 2. 3 6 are 18. 3 2s are 6 plus 1. 3 3s are 9. So answer for this question is 5. What happens if more than one answer option is of the form 3k plus 2? That is my next slide. 5 power 37 by 63. To get 63, first it should be of the form 3 into 3 into 7. So check with 3. 5 divided by 3. 3 twos are 6 minus 1. Minus 1 power odd is minus 1. Positive remainder is 2. Answer when divided by 3. Answer when divided by 3. It should give a remainder 2. Second question. Second, remainder when. I will do as many questions as possible. 53 power 11111 divided by 51. Options are 24, 26, 27 and 13. 24, 27, 26, 27 and 13. 51 is nothing but 3 into 17. 51 is 3 into 17. So this is remainder 1. 53 power 11111 divided by 3. 3 18s are 54. Negative remainder minus 1. Positive remainder 2. Answer when divided by 3, it gives a remainder 2. 24 out. 27 out. 13 out. Yes, you are right, Priya. If there is more than one answer option, which is of the form 3k plus 2, go to the next prime number, that is 7. If there is more than one answer option, which is of the form, right, 3k plus 2, go to the next one. Yes, Priya, what you have said is right. We can also go for it. Chinese remainder theorem. Once it is done, then it will be extremely clear to you. This is just like an acid test. Incorrect elimination of incorrect answer options. Third option, please write down. Third option. 5 examples if I solve, then we will do. Remainder of, in hurry students go like this. 32 power 32 divided by 9. 32 power 32 divided by 9. See here. 7, 3, 7, 32. Remainder of 32 power 32 divided by 9. which is 7. Another is 3. Another is 8. Another is 6. 9 is nothing but 3 into 3. 3 into 3. Check by using 32 power 32 divided by 3. 3 11s are 33. Minus 1. Minus 1 power even is plus 1, which is of the form 3k plus 1. These not possible. Not possible. Not possible. Answer for this question is 7. First we are doing only one answer option is matching. First step is only one answer option is matching. Second step is two answer options are matching. Two answer options are matching. Third one is without answer options. 3 methods I will explain so that you will not get a single doubt. 3 methods I will explain. Jashwant, you have asked a very good doubt. I will take, definitely your doubt I will take when I am taking the example without using answer option. First I will do only one answer option is matching. Then I will do two answer options are matching. Two answer options are matching. Then I will do without answer options. Right? Then we will do without. Yes, Arif, I will tell you why we should divide by 3. See, it's simple common sense. If a number is not divisible by 3, how can it be divisible by 9? 9 is a derived number. 9 is not a real entity. 9 is a derived entity. A prime number is a real entity. 2 is a real entity. 3 is a real entity. 6 is a derived number from 2 and 3. 10 is a derived number from 2 and 5. 15 is a derived number from 3 and 5. There are no composite numbers. There are only prime numbers. Composite is derived numbers. Prime is original. Composite is derived. Right? Yes, digital sum can also be used. Hold on, sir. Till I complete the concept. Till I complete the concept. Cherry 1, 2, 3. 32. 3 tens are 32 power 32 will give a remainder 1. Why it will be 3k plus 2, Harshit? You tell me why it will be 3k plus 2. After solving so many problems, how you are saying that it is 3k plus 2? 50 plus problems you have listened to the class. Still you are getting a doubt? Now see here. Allow me to complete the entire topic. Don't disturb the flow. First, after the entire topic is over. Next one. Harshit, for you, 3 tens are 30. 2 power 32 divided by 3. 2 is 3 ones are 3. Negative remainder. Minus 1 power 32 divided by 3, which is 1. Right? Question. Remainder 1. 7 power 2008 divided by 100. 7 power 2008 divided by 100. 0, 1, 31, 51. 51, 71. 7 power 2008 is 100. 100 can be written as 2 into 2 into 4 into 5. You can also take a combination of 2 into 2, 4. 4 into 5, 25. Still the answer will be same. Still the answer will be same. Let me take combination of 4 and 25. 7 power 2008. 7 power 2008 divided by 4. 4 2s are 8 minus 1. Positive remainder is 1. Answer when divided by 4, it should give remainder 1. Answer when divided by 4, it should give remainder 1. These out, these out. 51 is out. Assume if there is one more option, 41. This is what somebody has asked me. If two options, these for you, Ashwini. Anand, good doubt, I will discuss your doubt. 41. Then I will divide it by 25. 7 square power 1004 divided by 25. 49 divided by 25. 25 twos are 50 minus 1. So another should be of the form 25b plus 1. These are not 25b plus 1. Why did I do 4 into 25? Because I told you that in Chinese remainder theorem, denominator can be written as product of coprimes. 4 and 25 are coprime to each other. 4 and 25 are coprime to each other. Chinese remainder theorem helps us in solving a lot of questions by just having a look at answer options. Just by having a look at answer options. Answer when divided by 4, it should give a remainder 1. Answer when divided by 25, it should give a remainder 1. 4 options are eliminated. Those of you want to know, this is an original CAT question. This is how I solved it. 31, 51, 71. Actually, if you go by the regular textbook, it takes 2 minutes to solve. If you know Chinese remainder theorem, less than 10 seconds, you can solve it. One more question. Please write down. One more question. Please write down. One more question. I think I forgot to discuss one concept to you, that also we will discuss. Note, please write down this note. Morning, one student asked me in WhatsApp this question. The question is, 4 power any natural number. 4 power any natural number when divided by 6. It is always 4. Please make a note of this point. 4 power any natural number when you divide by 6, remainder will be 4. 4 power any natural number when you divide by 6. When you divide by 6, remainder is 4. Remainder is 4. Now we will see. This is the doubt asked by a student. You will not get a single doubt in my class, sir. I have an exceptional understanding of the concept, whatever I am teaching. Remainder 1. We will take an example. 4 square divided by 6, which is 4. Remainder 1. 4 cube divided by 6. 64 divided by 6. 6 tens are 60. Remainder 4. The question which a student asked is 4 power 13 power 17 divided by 6. Divided by 6, not 16. It is 6. It is 6. 4 power 13 power 17 divided by 6. Options are like this. 4, 6, 2, 3. 4, 6, 2 and 3. Now see here. 4 power 13 power 17 divided by 6. Options are 4, 6, 2 and 3. Now see here. 6 is nothing but 2 into 3. Listen carefully. 4 divided by 2. 4 is divisible by 2. Remainder is 0. Answer should be divisible by 2. This is out. 4 power 13 power 17 when divided by 3. 3 ones are 3. Remainder 1. So answer when divided by 3, it should give a remainder 1. This is out and this is out. 4 power any natural number divided by 6 is 4. 4 power any natural number divided by 6 is 4. I hope it is clear. 4 power any natural number divided by 6 is 4. 6 is 2 into 3. 4 is divisible by 2. 4 when divided by 3 it gives a remainder 1. It should be an even number and it should be of the form 3a plus 1. So few students doubts of why should I take only the first number. You can take any number. I hope it is clear. Now this is keeping an eye on the answer options. Now let us solve without answer options. See the first one. Here I will explain Anand Jaswant's doubt. Chinese remainder theorem application. Chinese remainder theorem application. First question. 53 power. Praveen, 53 power 11111 divided by 15. Divided by 15. Charging it. 50. Chinese remainder theorem is used when the denominator is a composite number. When the denominator is a composite number, I can use this logic. How to use this logic? 51. Chinese remainder theorem says, convert the number as a product of coprimes. Convert the number as a product of coprimes. Convert the number as a product of coprimes. What do you mean by coprimes? HCF of two numbers if it is 1. Then the numbers are said to be coprimes. Then the numbers are said to be coprimes. 53 power 11111 divided by 51. 51 is 3 into 17. First we will do with this number. This is nothing but 53 power 1111 divided by 3. 3 18s are 54. Negative remainder minus 1. If negative remainder minus 1, positive remainder will be 2. Positive remainder will be 2. So answer when divided by 3, it should give remainder 2. We will see later. Next one. 53 power 11111 divided by 17. So this is 17 3s are 51. 17 3s are 51. Praveen, ఈ పెన్ను చూడు. 17 3s are 51. 51 రాయట్లేదు. 51. Remainder is 2. So here it is 2 power 11111 divided by 17. Till here clear, right? So this will become, with one answer option we did, with two answer options, 2 power 1111. This is nothing but 2 power 4 power 277 into 2 cube divided by 17. 16 divided by 17 minus 1 minus 8. Positive remainder is 9. Positive remainder is 9. This step, is it clear? 51. 51 is a composite number. I wrote composite number as a product of coprimes. So I wrote it as 3 and 17. 53 divided by 3. 3 18s are 54. Negative remainder minus 1. Positive remainder 2. 53 divided by 17. 17 3s are 51. Remainder is 2 power 111 divided by 17. Either you can use a negative remainder or Fermat's theorem. 2 power 4 power 277 into 2 cube by 17. 16 by 17 is minus 1. Minus 1 power odd is minus 1. Minus 8. Positive remainder is 9. Positive remainder is 9. Now I will explain just once doubt. 53 power 11111 divided by 51. 51 is 3 into 17. 3 into 17. So positive remainder, it will be 2 and it will be 9. A number when divided by 3, it gives a remainder 2. A number when divided by 17, it gives a remainder 1. So 3a equivalent to 17b plus 7. 3a equivalent to 15b plus 6 plus 2 into b plus 1. 2 into b plus 1. This is divisible by 3. This is divisible by 3. This is divisible by 3. This should be divisible by 3. B plus 1 is 3. B minimum value is 2. Sorry. 3a plus b. I think it is 2b plus 1. I wrote a mistake here. It is 2b plus 1. I wrote it as 2b plus 2. 2b plus 1. Divisible by 3. Divisible by 3. Divisible by 3. 2b plus 1 should be divisible by 3. So b minimum is 1. Anand, for you, if b minimum is 1, the value will become 17 plus 9, 26. That means this number is, lowest number is 26 and it is divisible by 3 and 17. Divided by 51. This will get cancelled and it will give an answer 26. And it will give an answer 26. I hope the idea is clear. Anand, why we are taking 3a plus 2, 17b plus 9? I hope it is clear. 51 is 3 into 17. 53 divided by 3. 3 18s are 54 minus 1. Minus 1 power odd is minus 1. Positive remainder is 2. 17 we got 9. One is when divided by 3 remainder 2. Another is when divided by 17 remainder 9. So 3a equivalent to 17b plus 7. 3a equivalent to 15b plus 6 plus 2b plus 1. So what it will become? These divisible by 3, divisible by 3, divisible by 3. Remaining is 2b plus 1. 2b plus 1 should be divisible by 3. B minimum should be 1. If b minimum is 1, then the value will become 17 plus 9, 26. 17 plus 9, 26. All the time it is divisible by 3 and 17. So plus LCM of 3 and 17. These both is getting divided. Therefore, the answer is 26. That's exactly the reason. Here only we are checking by using answer options. Here only we are checking by using answer option. When divided by 3, positive remainder 2. When divided by 17, positive remainder 9. Here only we are checking. I hope it is clear. Still we will do some more examples so that it will be absolute clarity to you. Absolute clarity to you. I hope this concept is clear. Second one. Second one. See the question. 13 power 400 divided by 187. 187 is a composite number. It has to be written as a product of coprimes. 11 into 17. So this will become 13 power 400 divided by 11. Divided by 11. 11 means power has to be 10 according to Fermat's theorem. 13 power 10. Power 40 divided by 11. This is 1. 1 power any number 1. 1 power any number 1. Next is 13 power 400 divided by 17. 17 means according to Fermat's theorem, power should be 16. 13 power 16, power 25 divided by 17. Again it is 1. Are you with me? So answer when divided by 11, it gives a remainder 1. Answer when divided by 17, it gives a remainder 1. This is cancelled. Answer is 11a equivalent to 17b. Either a is 0 or b is 0. 0 plus 1, 1. So this is nothing but 1 plus LCM of 11 and 17 into k divided by 187. This will get cancelled. Answer is 1. Second problem, I hope it is clear. 13 power 400 divided by 11. 11 means power should be 10. 13 power 10 power 40. 13 power 10 divided by 11. It is 1. 1 power any number is 1. 13 power 400 divided by 17. 17 means power is 16. 13 power 16 by 17, it is 1. 11a plus 1 equivalent to 17b plus 1. 1 cancelled. Either A0 or B0. Answer is 1. Here itself you can check by using answer option. Answer when divided by 11, it should give remainder 1. Answer when divided by 17, it should give remainder 1. I hope it is clear. Only one answer option is matching. Two answer options are matching. When answer options are not given. All the three methods, I hope it is clear. Now, third question, fourth question, practice question. One by one we will go. Third one, reminder when 3 power 101 is divided by 77. 77 is 7 into 11. Composite number should be written as a product of coprimes. So when divided by 7, this will become 3 power 101 when divided by 7. 7 means power should be 6. 6 16s are 96 into 3 power 5 when divided by 7. 3 power 6 by 7, it is 1. 243 by 3. 7 3s are 21, 33. 7 4s are 28. Positive remainder is 5. Positive remainder is 5. You can use by using negative remainder, answer does not change. This is 3 power 101 when divided by 11. 11 means power should be 10. 3 power 10 into 3 power 1 when divided by 11. This is 1. Again a remainder 3. Again a remainder 3. Don't solve the equation. If answer options are given, check which answer option. When divided by 7, I get remainder 3. When divided by 11, I will get a remainder 11. Remainder is 3. When 7, remainder is 5. When divided by 7, remainder is 5. When divided by 11, remainder is 3. 7a equivalent to 11b minus 2. 7a equivalent to 7b plus 4b minus 2. These is divisible by 7, divisible by 7. 4b minus 2 is divisible by 7. 4b minus 2 is an even number. So 4b minus 2 should be 14. So b minimum value is 4. B minimum value is 4. 11 4s are 44 plus 3, 47. Third one answer is 47. Third one answer is 47. I hope this idea is clear to you. I hope this idea is clear to you. I will take up your doubts after I solve fourth problem. Third problem, I hope the idea is clear. If the denominator is a composite number, write the number as a product of coprimes. 77 is 7 into 11. 3 power 101 by 1 by 7 you do. 3 power 101 by 11 you do. 3 power 101 divided by 7, I got remainder 5. 3 power 101 divided by 11, I got remainder 3. Next one, fourth question. Fourth one. Remainder 1. 128 power 100 divided by 153. Divided by 153. 153 is a composite number. So it is 17 into 9. Do with 17 and do with 9. Remainder when 128 power 100 divided by 17. 17 sevens are 119. Remainder is 9. Remainder is 9. 17 means power will be 16. 16 6 are 96. Remainder is power is 4. Directly I am writing. Divided by 17. These are nothing but 9 square whole square divided by 17. 81 divided by 17. 17 5s are 85. Minus 4. Minus 4 whole square is 16. Minus 4 whole square is 16. That means when divided by 17, remainder will be 16. Next case, when divided by 9. 128 power 100 divided by 9. 9 14s are 126. It is 2. 2 power 100 divided by 9. Already we discussed in Euler's theorem, 9 quotient function is 6. 6 16s are 96. These are nothing but 2 power 4 by 9. 16 by 9. Remainder is 7. So the next case, which is 9b plus 7. So 9b equivalent to 17a plus 9. Divisible by 9, divisible by 9. A value is 0. 0 into anything plus 16. It is 16. Praveen, ఒకసారి phone తీసుకో. Now you can ask me any doubts in Chinese remainder theorem. Please ask me any doubts in the live chat in the Chinese remainder theorem. Four questions we did it. How to use Chinese remainder theorem to eliminate incorrect answer option. First is, I did not wrote it as product of coprimes. I just wrote it as product of prime numbers, used the primitive rule. If a number is not divisible by 3, how can it be divisible by 9? If a number is not divisible by 6, how can it be divisible by 12? I used the common sense to tell that what could be the answer option. I will never be able to tell that this is the answer option, but I can tell that this is not the right answer option because of rule not satisfying. I hope it is clear. I hope it is clear. Kindly reply it in the live chat so that I will take up any doubts if need be. Right? Exceptional content, outstanding conceptual clarity. Right after the class, you can tell to someone that this is the concept and this is where it is used. That confidence I will give you in my class. That is the confidence I will give you in my class. Kindly reply it in the live chat if you got any valid doubts. Any student got any doubts? Kindly clear, right? Now, is it clear? Right. I think Arif. Remainder problems. See here, sir. Remainder problems. Remainder problems. If the question is remainder when numerator power x divided by denominator. Two cases. If the denominator is a prime number, if the denominator is a prime number, if the denominator is a composite number, if the denominator is a composite number, If it is a prime number, use a negative remainder. If it is failing, use Fermat's theorem. Use Fermat's theorem. Use Wilson's theorem. Use Wilson's theorem if the numerator is in factorial format. If the numerator is in factorial format. First this, then this, then this. If the denominator is a prime number, first use negative remainder, then use Fermat's theorem, then use Wilson's theorem. If it is a composite number, Praveen okkari pennu చూడు. If it is a composite number, you can use first is a negative remainder. Then you can use Euler's theorem. Then you can use Chinese remainder theorem. Take this table, sir. Chinese remainder theorem. There is no confusion. Absolute clarity is there. Negative remainder, Euler's theorem and Chinese remainder theorem. These are the various kinds of remainder questions that comes into your aptitude exams. There is one more theorem which I generally discuss it for students who are writing MSc examination. That is Carmichael's theorem. That is not required for this examination. Negative remainder, Fermat's theorem, Wilson's theorem and Chinese remainder theorem. To check the answer options, if answer options are given, use Chinese remainder theorem. Please take a screenshot of this image after I complete this. I will write it neatly, then you take a screenshot. Negative remainder. Next it is Euler's theorem. Next it is Chinese remainder theorem. Please take a screenshot right now. Kindly take a screenshot of this. Wilson's theorem, today evening 6:30 class I am going to discuss. 6:30 class I am going to discuss Wilson's theorem. If the denominator is a prime number or a composite number, the first method which you will use is negative remainder. If it is failing, you will go to Fermat's theorem. There is one more theorem which the denominator is a prime number. Today evening 6:30 we will discuss Euler's theorem and Chinese remainder theorem. If answer options are given, use Chinese remainder theorem like the way we use digital sum. Please take a screenshot. Kindly take a screenshot of this image. Reply in the live chat once it is done. If you have taken screenshot, reply it. If you have taken a screenshot, reply it. You take a screenshot, reply it. Srikanth, good question. I will take up a question. I'll take up your doubt. Srikanth asks, what if the denominator is a 2 power 381 divided by 3 factorial. 3 factorial is nothing but 6. 2 power 381 divided by 2 into 3. 2 divided by 2, perfectly divisible. 2 divided by 3, 3 ones are 3, negative remainder minus 1, positive remainder 2. Equate it, you will get the answer. Or 7 power 120 divided by 4 factorial. 4 factorial is 24, which is nothing but 8 into 3. 7 divided by 8, negative remainder is minus 1. Minus 1 power even is plus 1. 7, 3 2s are 6. Positive remainder 1. So it is 3b plus 1. Equate it, you will get the answer. I hope it is clear. Everybody, it is clear to you. Right? Effective from tomorrow. Effective from tomorrow. You have to come and listen to the live class. The class is free to watch it for once. Class is free to watch it for once. After that, it will be available only to enrolled students. Only to enrolled students. The model is quite similar to an Hotstar model. You can watch a match for 15 minutes or 20 minutes. To watch the entire match, you have to pay a subscription for it. This is how I operate for it. I am not here for charity. The employees who work under me is one guy who is an MBA from Oxford University. Another is an MBA guy from Stanford University. Oxford University and Stanford University are my team members. Or possibly I will give them direction of how to think and how to scale up the organization. Don't discuss anything. Interested, purchase. Not interested, don't purchase. Scale khatam, that's all. There is no other discussion. Right? Now, see here. There are few more questions. 5, 6, 7, 8. This 8th question we will solve. 111 is nothing but 3 into 37. So here it is 17 power 36 plus 19 power 36 divided by 3. 3 6 are 81 minus 1. Minus 1 power even plus 1. 3 6 are 18 plus 1. 1 plus 1 2. So 1 is 3k plus 2. 1 is 3k plus 2. Another is 17 power 36. 19 power 36 divided by 37. This is 1 and it is 1. This is also remainder 2. 37b plus 2. 37b plus 2. 2 2 over. So it is A0 or B0. 3 into 0 plus 2, 2. Answer is 2. 8th one, another application. 8th one, another application. I hope it is clear. 8th one, another application. It is clear. Now, are there any questions are there? 1, 2, 3, 4, 5 and so on up to 40 divided by 36. 5th one I will solve. Remainder 1, 1, 2, 3, 4, 5 and so on up to 40 divided by 36. 36 is a composite number. It can be written as a product of coprimes. 4 into 9. Divisibility rule of 4 is last 2 digits should be divisible by 4. 40 is perfectly divisible by 4. 1 is 4a form. 9 is sum of the digits. Sum of the digits is summation 40. Summation n starting from 1 to n is nothing but n into n plus 1 by 2. 40 into 41 by 2. 820. 820 digital sum is 1. 4a equivalent to 9b plus 1. 4a is nothing but 8b plus b plus 1. divisible by 4, divisible by 4. B minimum value is 3. 27 plus 1. Answer is 28. Answer is 28. Answer is 28. When I was taking this session in an IIT Madras, some years before, one student asked me a doubt. I think it was way back in 2015 or 16. I will take up that doubt right now. I will take up that doubt. 1, 2, 3, 4, 5 and so on up to 40 divided by 36. Divided by 36. Praveen, your phone charging bettesi. Summation 40. I hope it is clear. The doubt what he asked is, sir, the doubt seems like a very interesting doubt, but 1, 2, 3, 4, 5 and so on up to 40 divided by 36 is 4 into 9. So 9 is sum of the digits, divisibility rule. 9 is sum of the digits. Now he asked me, sir, 1, 2, 3, 4, 5 till 9, okay. Next it is 10. 10 digital sum is 1. 11 digital sum 1 plus 1 is 2. 12 digital sum is 3. Sir, should I not do like that? I said, you do digital sum in whatever way. 1 plus 2 plus 3 plus 4 plus 5 or 12 plus 34 plus 5 or 1 plus 2, 3, 4, 5 or 123 plus 45. Answer digital sum does not change. Please check it out. 5 plus 4, 9. 9 plus 3, 12. 12 plus 2, 14. 14 plus 1, 15. 15 digital sum is 6. Here also 34, 39, 51 it is 6. Here also it will be 6. Here also it will be 6. In whatever order the digits are added, digital sum does not get affected. Digital sum is unaffected. If you add 2 digits at a time or 3 digits at a time or 2 and 3 digits at a time, digital sum is not affected. I hope his doubt is clear to you. Sixth problem. 2002 is 2 into 1001. I will explain the divisibility rule of 1001 at a 6:30 p.m. class. Don't miss 6:30 p.m. class. 6:30 p.m. class is extremely important to you. 6:30 p.m. class is extremely important to you. I hope you got an idea. So we have got one problem and we have got 2 more varieties. In reminders, 2 more varieties are left. That is, when numerator, denominator are not co-prime, when numerator and denominator are not co-prime, problems related to a power n plus or minus b power